On May 21st, 2014, eBay actually announced that its network had been breached by attackers and that those attackers were able to access customer data from an internal database within the company. So what I wanted to do in this video is explain what's been said publicly about this attack and help you better understand its implications. For starters, the attackers began their efforts by compromising the usernames and passwords of employees within eBay. Now, it hasn't been stated publicly how they got those usernames and passwords, but typically in attacks of this nature, they typically involve some type of phishing or social engineering scheme. In this case, the attacker will send an email message to the victim, who in this case would be an eBay employee, and this email message will contain a link inside of it that, when clicked, will lead to the user downloading a piece of malicious software or malware onto their system. And then once that malware gets installed, the attacker can access the victim's computer, essentially using it as a beachhead for gaining further access into an internal network, like eBay's internal network. And then with this access, attackers can look for what interesting data can be found on that network. For example, they can look for databases that contain usernames and passwords of customers, and so on and so forth. Now, in the reports about this attack, eBay suggested that users change their passwords, but it was also said that the passwords were stored in encrypted format in the database. And the implication here is that even if the attackers were able to access the data, they may not be able to figure out the actual customer passwords because that data was not easily made available to them. I want to explain what that means. First of all, I want to point out that the use of the term encryption here is actually not correct. What typically happens in these scenarios is a paradigm known as hashing and salting. When a user enters their username and password upon, let's say, logging into their online account, the web server, in this case eBay's web server, will take that password and mathematically transform it using what's known as a hash function. And you may have heard of hash functions before. Common examples include ththings like MD5, SHA-1, SHA-256, and so on and so forth. And what these hash functions do is literally they hash the input, and then they produce what appears to be a very random looking output. If a hash function is well designed, then not only will its output be random looking, but you will not be able to infer any information or glean any insight about the input that went into the hash function given just the output that came out. Instead of storing the password itself in the database, companies like eBay will often store the hash of that password. And so when a user comes along and types in their password to log in, that password will be hashed, and then the web server will check if the password hash matches what was previously stored. If the hashed password does match what was previously stored, then the user will be allowed to log in. If the hashed password does not match what was previously stored, then the user will be denied access to login. And the core idea here is that if the user typed in the wrong password or didn't know the correct password for any reason, then the hashes of the password will not match. In other words, the hash of the thing that was typed in by the user will in all likelihood fail to match the hash of the correct password that was previously stored in that database. And so the benefit of storing the hashed password is that if the attacker gets access to the hashed password, they will not be able to easily glean any information about the original, the actual password itself. In other words, while it's easy to go from the original password to the hashed password, it's actually not easy to go the other way around. It's hard to invert this hash function. It's hard to figure out the original password given just the hash. But at the same time, it is important to note that it's not impossible to do so either. It's not impossible to essentially reverse the hash function. The way that this is done is, instead of trying to reverse the hash function directly or to invert it somehow directly, an attacker can instead take the hashed password and try to guess by brute force what the original password might have been. Now, people typically choose passwords that are easy to remember. For example, they may choose a password that's short, or maybe it only contains letters, maybe a couple of numbers. It might include some common words found in the dictionary. So it's within the realm of possibility for an attacker to correctly guess which password matches the hash by simply trying all reasonable guesses for the password until they find one that matches the hash that was stored. Now, the key word here is reasonable. Attackers won't try all possible passwords. That would take too long. But what an attacker can do instead is just try passwords that might be more reasonable for a person to have chosen. For example, instead of trying a password guess for a complex looking sequence of numbers and symbols and letters and so on, the attacker can try simpler passwords like hello 1234. And by the way, all of this can be automated. An attacker can easily try many tens of millions of possible reasonable password guesses, and all he's got to do is find one whose hash matches what was previously stored. And this type of attack, in which all reasonable passwords are tried, this type of attack is known as a dictionary attack. So eBay and other companies like it also employ a mechanism known as salting in addition to hashing. And what this salting mechanism entails is adding a few extra random characters to the end of the user password just prior to hashing it. And these random characters are known as salt. And what this salt is meant to be is it's meant to be something that's unique to a particular company. So for example, eBay would have a unique value of salt for itself. Other companies would pick their own unique salt value. And what this step does is it makes it harder for attackers because they can't simply recycle any previous effort that went into hashing simply because that salt might have been different in any previous effort. So they have to essentially redo all their work, but leveraging the salt that they know about for that one particular company. Now, all that said, while it's more difficult to compromise the security of a password that's been both hashed and salted, it's not impossible to do so, especially for a motivated attacker. So I would still recommend that you change your password. I also imagine that eBay and similar companies have capabilities in place to look for suspicious account activity, so that even if an attacker got your password, you would still have protections in place. Now, even though I've been mentioning eBay, I do want to point out and stress that attacks of this nature happen all the time and to many different companies. The question is no longer if you're going to get compromised, but rather when you'll get compromised. And in that vein, what matters more is not just being able to deal with the compromise, but being able to get to it very quickly and to respond to a breach in a timely fashion.